Automatic speech recognition system with dynamic time warping and Mel-Frequency Cepstral coefficients. Automatic speech recognition allows a machine to understand human speech and accordingly implement different actions and interactions between on the intended application. Voice recognition is the process of recognizing words spoken by a person by extracting features from the speech signal and performing a comparison with a predefined database. Based on this comparison, speech can be identified. The task of optimizing the quality and level of recognition in automatic speech recognition systems is a relevant scientific and practical task, the solution of which allows improving the quality of the developed speech, image, language, knowledge interfaces of software systems and applications. The main goal of the paper is to present the results of developing a system for automatic recognition of user voice commands for a graphical editor. To achieve this goal, the following design objectives have been identified and successfully completed. A model of an automatic speech recognition system with characteristics has been designed. Creating an algorithm to transform input voice command into program command. Development of the vocabulary for the speech recognition system. Implement a system with a high-level programming language. System testing and an accuracy evaluation. The automatic voice recognition system is an information system that converts an incoming speech signal into a recognized message. Automatic voice recognition systems are classified according to the following characteristics. Dictionary size depends on the announcer, language type, purpose, recognition algorithm that is used. A model of the developed automatic speech recognition system can be described as follows. System has a limited dictionary size, is a speaker dependent, is a command system that is used to recognize separate short speech commands. The list of commands contains 20 commands in Ukrainian language, the name of which corresponds to the name of the pictograms of the graphical editor. When analyzing an analog signal from speech, properties are extracted that are used further in the recognition process to determine what was said. The general scheme of the speech signal recognition process is next. Receiving the acoustic signal that comes from the user's microphone, digitizing the sound signal, obtaining the characteristics of the signal, and comparing the feature vector of the input signal with templates. The input data for the proposed system are the user's voice commands entered through the microphone. Since the system must process voice signal in real time, it is proposed to use Fourier's theorem to analyze the speech signal. As a result, we will get a set of amplitudes, phases, and frequencies for each sinusoidal wave component. To restore a discrete signal from the spectrum, we use the inverse Fourier transform. To significantly speed up the spectrogram construction process, the fast Fourier transform algorithm was used, which works with complex numbers and transformation size representing powers of 2. To change the size of the spectrum removed after the fast Fourier transform, the Hamming window was used. Applying a Hamming window reduces the level of spectral blurring by about 40 decibels relative to the main peak. The input signal was divided into intervals of 20-14 milliseconds, since the size of such an interval is sufficient to obtain a reliable spectral estimate. The sound signal is constantly changing, so for simplicity, let's assume that the sound signal hardly changed over a short period of time. That is why the paper suggests dividing the signal into intervals of 20 till 30 milliseconds. If the frame is much shorter, we don't have enough samples to get a reliable spectral estimate. If longer, the signal changes too much over the entire frame. Spectral estimation determines which frequencies are present in the frame. Spectral estimation still contains a lot of information that is not needed for automatic speech recognition. In particular, it is not possible to distinguish between two closely spaced frequencies. This effect becomes more pronounced with increasing frequency. In this paper, it is proposed to use Mel-Frequency Cepstral coefficients, a method that allows extracting features that an acoustic signal received from a speaker has. After building the filter bank, it is possible to proceed to compare the process commands with templates. After calculation the energy of the filter bank, it is necessary to calculate their logarithm. Since humans do not hear loudness on a linear scale, this operation makes Mel coefficient more similar to human perception of sound. The last step is to calculate the discrete cosine transform of the energy of the logarithm in the filter bank. In the process of language recognition, the most difficult thing is to carry out the procedure of comparing two language elements, which are also characterized by a lag in time. Therefore, there are quite a lot of such procedures and methods. Dynamic time warping is a pattern matching algorithm with a nonlinear time normalization effect. The dynamic time warping algorithm creates an alignment between two sequences of feature vectors. It results in a time warping vector describing the time alignment of segments of the two signals, assigns a certain segment of the source signal to each of a set of regularly spaced synthesis instances in the target signal. The developed system is equipped with functions: formation of a dictionary of announcer commands, training of the system for a specific announcer, and execution of recognized commands. The automatic speech recognition system is used as a software module for the implementation of a graphic editor plugin, the use of which allows you to use the functionality of the graphic editor through voice control commands. The developed voice recognition system has a limited command dictionary size aimed at recognizing 20 isolated command words. The developed application has the following functional requirements: the possibility of training the system for a specific announcer, recognition of received voice commands, conversion of voice commands to commands of a graphic editor. The presented class diagram was generated automatically within the software environment visualstudio.net during the software implementation. The architecture of the class does not contain inheritance relations. To increase the software flexibility, the composition relations were implemented for interaction between classes. A composition relationship is a relationship in which a data consumer class has a data provider class type field. This type of relation is not displayed in the class diagram generated in the visualstudio.net. The result of the developed program code execution is a new item displayed, the Add-ins menu item in the main toolbar of the graphic editor. After clicking the Add-ins button, the start button is displayed, which activates the command recognition mode, and preferences, which start the application setting mode. The software application was tested in the following mode: 20 test commands, 10 announcers, 10 requests to pronounce each command. The sampling frequency of speech signals is 44.1 kHz. The resolution of the speech sample is 16 bits. The number of channels is 2. The functionality of the developed plugin is divided into two parts: system training with the ability to create and save a command template, and command execution mode. This part of the software is implemented as a desktop application within Windows application for C# programming language. By pressing the start button and starting the voice command recognition mode, you can speak commands and evaluate the result of their execution. The recognition mode stops function when the stop button is pressed. In the program setting mode, it is possible to change the voice signal transmission device, add the voice equivalent for the command to the dictionary, analyze the sound wave and its spectrum as it is shown on the figure. In order to establish the adequacy of the proposed solutions and estimate the speech signal recognition error, a transaction log was developed, which received a description of each speaker command recognition operation. Recognition accuracy values can be determined as it is shown. The results of the conducted experiment are shown on the table. The obtained result of recognition and its comparison with the recognition accuracy of system using DTV and Mel-Frequency Cepstral coefficients allows to draw conclusions regarding the adequacy and efficiency of the proposed design solutions. Combining different approaches allows to achieve the desired level of recognition accuracy. The paper presents the results of the development of an automatic speech recognition system using DTV and Mel-Frequency Cepstral coefficients. The proposed system is speaker-dependent, has a limited dictionary, and is designed to recognize 20 short user commands specified by the user in Ukrainian language using a microphone. The developed system is used as a program module of a plugin for a graphic editor. The use of such a plugin allows to control the functionality of the graphic editor through the user's voice commands. The language of the software implementation is C#. The software has been developed using the object-oriented approach within the Windows application Word as a desktop application to set options and record the results of the experiments, and as a plugin for the graphical reductor. The average value of accuracy for all commands and recognition variants was approximately 93%. However, the obtained level of recognition indicates a high efficiency of the proposed solution and also demonstrates the promise of DTV and Mel-Frequency Cepstral coefficient approaches combining for speech recognition in Ukrainian language.